Welcome back. This week we will first talk about physical attacks. From studying various ways of physical attacks, you will see the threats from hardware or how to break security from hardware side. You will also learn some of the countermeasures to these attacks. Probably one thing that you may find very useful is how industry and government define and evaluate the security levels of a product. Most of the physical attacks require special skills and knowledge in addition to sometimes very expensive equipment and tools. However, you do not need to have any special background to understand most of these attacks. Our goal in this lecture is to let people be aware of these attacks, not to teach them step by step how to do such attacks. Next week, we will discuss in more details about set channel attack, which is a very powerful physical attack. Over the years of lecturing on hardware security, I find it is very difficult to deliver this part of the material without a lab for demonstrations. For this Coursera course, I also take away some of the images. Part of this course is developed based on a book chapter by Sergei Skorobogatov. On his webpage, Sergei has also posted his lecture notes on physical attacks and temper resistance. If you are interested in this topic, you should definitely read this book chapter. Let's start with the question, what are the physical attacks? I cannot give you an accurate definition, but all the physical attacks have the following characteristics or require the following conditions. First, to launch a physical attack, the attacker needs physical access to the chip, or at least should be able to connect certain wires in order to measure the target signals. With more and more devices being connected wirelessly nowadays, physical attacks without physical access to the system have also been reported. For example, acoustic attacks, near-field communication attacks, and some attacks to the RFID can all be performed close to the device without touching them. In addition to the necessary equipment and the tools, the attacker must also have the required skills and knowledge to perform physical attacks. The second common thing about all the physical attacks is that they all have two phases. First, the interaction phase, where the attacker interacts with some physical characteristics of the device to collect data. And then the exploitation phase, where the attacker analyzes the collected information to reveal the secret and break the security. From this, without discussing any physical attack in details, what can we say about physical attack and hardware security? First, we can imagine that these requirements make it harder to attack the system from hardware than from software or network. We have said that physical attacks needs physical access to the system, and also most of the time need specialized equipment, tools, and knowledge to perform the task, the attack. And normally for software attack or network attack, the bar is much lower. On the other hand, we know that the attacker's loss will always be our gain. In this context, this means that with the same cost and effort, investing on protection from hardware will most likely make the system more secure than adding security from network and software layers. This is also one of the reasons why hardware security has gained a lot of attention in the recent years. However, the downside of building security at hardware is that this will also add another attacking surface. We have to make sure that the hardware is secure and trusted, which means that we should consider the vulnerabilities in hardware design and implementations. and make sure that the backdoors will not become new threats. Attackers, not necessarily who launch physical attacks, can be categorized into three groups. Class 1. Clever outsiders. These attackers are often very intelligent, but they may not have sufficient knowledge about the system. They may not have access to the equipment and the tools necessary to break the system either. Class 2. Knowledgeable insiders. These attackers are familiar with the system and have highly sophisticated tools and equipment to analyze and break the system. Class 3. Founded organizations. They normally have a team of experts with all the necessary skills, tools, knowledge, and equipment to invent new attacks if necessary to break the target system. So what are the motivations for all these kind of different attackers to break a system? There's one single motivation: money. Actually, this is also the motivation for almost all the attacks. Based on how money can be made from successful physical attacks, we can further partition the motivation for physical attacks into several groups. First, steal money or service directly. Examples of this type of physical attacks include breaking smart cards and making bogus deposit, or breaking the TV set-top box to watch programs without subscribing, or breaking game console to play games without paying. Second, make profits by selling or reselling products illegally. IP piracy, integrated circuit overbuilding, and counterfeiting are all examples of this kind. Third, boost own sales by interrupting or damaging the service provided by the competitors. For example, an attacker can insert malicious update, patches, or hardware trojan to make competitors' device or system malfunction or suffer bad performance. This will give their own product an unfair competitive edge. We have discussed IP protection last week, and we will cover hardware trojan later. This week, our focus will be on how physical attacks can break the system, particularly crypto systems, to steal service or money directly. When we say breaking the system, we do not mean physically destroying the system. Instead, the attackers want to learn information about the system that he doesn't have the authority to access. In the case of crypto systems, such information could be the secret key or the secret data. In the case of design IP protections, it would be the design details. Before further discussing physical attacks, we would like to point out the difference between physical attacks and cryptanalysis. They both have the goal of breaking the security. However, classic cryptanalysis focuses on breaking the crypto system by mathematical analysis of the cryptographic algorithms. It had success in the past, for example, the birthday attack and the differential cryptanalysis. But now cryptanalysis is becoming harder and harder. This is because most of the modern crypto systems are theoretically sound and unbreakable. Instead, there may exist flaws in the implementation of the crypto systems. Physical attacks attempts to find such flaws and break the system. Based on whether the target system or device will be damaged during or after the attack, physical attacks can be classified in three groups. Invasive attacks. This kind of attack requires direct access to the inside of the chip or device. Depends on whether after the attack the system can be reassembled. The attack can be either reversible, otherwise it's called irreversible. Apparently, for irreversible attacks, it cannot be repeated. Normally, the device will be damaged after the attack. Sometimes tamper evidence will left. The cost and required skills to perform invasive attack varies based on how the attacks will be performed on what kind of systems. But normally, the cost and effort will be very, very high. The second category is called non-invasive attack. In this case, the attacker will interact with the device or the chip with its interface, such as voltage, current, clock, input-output interface, etc. And such attack can also be passive or active, depending on whether the attacker only monitors and measures these physical characteristics, or the attacker also injects input to the system to cause the system malfunction. Normally, such attack will not damage the device and will not leave any tamper evidence. Most of these attacks have very low cost and can be repeated. And in the middle, between invasive attack and non-invasive attack, there's another category called semi-invasive attacks. These attacks normally they require access to the surface of the chip, but they do not need to create contacts with the internal wires. And usually they do not damage the system, and depends on how the attacker is performed, they may or may not leave tamper evidence. And the cost of this depends on what kind of surface, what kind of interact they will have with the system. They can be high or low, but they will be definitely much lower than the very expensive invasive attacks. And they also require some special skills. And most of the semi-invasive attacks, they are repeatable. There are a few ways to perform physical attacks, and based on how physical attacks are performed, it can also be put into several different categories. Reverse engineering. This type of attack will study the chip's inside structure and then trying to determine the functionality of the system. Normally, this has very high cost, and the attacker should have similar capability of the designer, and normally also have the capability of manufacturing. And this is in general is a invasive attack. The second group is called micro-probing. In this case, it requires direct access to the chip surface to observe, manipulate, and interact with the chip, and they are also invasive attacks. The third category is called fault generation. In this case, the attacker will create fault, normally faulty input, or make the chip run in abnormal environment conditions, and in the hope that the chip will malfunction to leak information, will give the attacker additional access to the system. Depending how the fault is generated, the attack can be either semi-invasive or non-invasive. And side channel attack, which we will discuss next week, they are normally non-invasive attacks. And this type of attack has two phases. First, the attacker will monitor or measure chip's physical characteristics, such as power, current, timing, EM radiation, etc., during the chip's normal operation mode. And then, with the data collected, they will perform a data analysis to learn the hidden information. And finally, there's a category called software attack. This again, it is non-invasive, and the attacker will use normal input-output interface trying to explore known security vulnerabilities in the security protocols or algorithms or their software implementations to perform attack. This attack, they are repeatable, they are non-invasive.